Hi guys, good evening. Let's start the session. So let me share my whiteboard first. Okay. Are you able to see the whiteboard? Am I audible?
Yes.
Yes. Okay, great. Fine. So the topic for today is recursion, right? Anyone want to explain about recursion? Then we can start the session in 1 or 2 minutes. If anyone have any knowledge about recursion. Okay. So recursion is a special approach, or we can say a special method through which we can solve some complex problem by dividing the problem into some smaller sub problem. So before solving anything, before writing any code, or before applying any kind of algorithm or data structure with the problem, we first need to know about the fundamental of that, right? Fundamental of that, and then we should know the exit condition and the entry condition. Like fundamental, for example, if we are talking about the stack, so what are the fundamental rules of that particular data structure or particular algorithm? Let's say if I talk about DP or any algorithm or data structure, so we should understand about the fundamentals of that particular data structure or algorithm. Then we should know how we can exit from that algorithm or that data structure, like what should be the operations, and how we can enter into that particular algorithm or data structure. So if I talk about the data structure, so how, entry means how we are going to add data, or we can push data inside the data structure, and how we can pop out or delete the data from the data structure. And basic fundamental, what are the basic rules, and what are the various operations which data structure has. When we talk about the some methodology or some algorithm, then entry means how we are going to start that particular operation. Let's say for example, when we are working on loop, so we always start with particular index, let's say from 1 or from n, from some value, and we go till a particular value, and we can exit after that. Similarly, in recursion, entry means how we are calling the function again. So basically, the recursion means it's called calling the function by itself. So for example, if let's say I have a function, let's say foo, and inside this function I am having some logic, and I am again calling foo, right? So the same function is calling itself. This logic is known as recursion. So we have already solved the problem on recursion, like DFS, BFS we have done. We have solved some problem on trees and all. So we already discussed the recursion, but the fundamental of recursion, that we should have some we prepare with the exit condition and the formula. So entry means the formula, like how we are breaking the problem so that we can again get the another call of the same function. And the exit one is very important. For example, let me scroll down. For example, if I want to calculate factorial of, let's say 10, so we know that the factorial is like this: 10 into 9 into 8 into 7 into 6 into dot 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 1, right? So that means if we are talking about fact 10, what we need to do? We need to call fact of n, n minus 1 into n, right? That this would be the formula. So we know about the formula, that okay, that is the formula. But if we are writing the code like this, then it will go into the infinite loop. Can anyone explain why we will get an infinite loop here? What is the like missing in this factorial function? Anyone? Or let's take another example, the very basic example. For I equals to 0, let's say I is greater than 0, I plus plus, and we are having some data here. Let's say we are sys.out.println, okay, xyz anything. So can anyone tell how much time it will take to execute the program? Uh, let's say I'm running the program right now, and when I can complete the get the complete output. Anyone? Just focus about this only. This will also go into an infinite loop. Can anyone tell me why it will go for infinite loop?
Because the exact condition will never be satisfied.
Yeah,
I's will always be greater than 0.
because we are not exiting from the loop, because every value, because we are increasing from 0, so every value would be greater than 0, right? Right? Or we can say greater than equals to 0, because if we have only greater than, then it won't go inside it. So greater than equals to 0, then it will be an infinite loop. We will not we are not going to break that condition, right? Similarly, can anyone tell what is missing here? How it will go for infinite loop?
Here there
so
is no exit condition.
Huh?
There
Sorry?
is no exit condition here right now.
Yeah. So what should so why we will go for infinite loop? Let's take an example of 3. Then we will go 3 into 2 into 1 into we should stop at 1, but we are not stopping because we don't have anything. So it will be -1 and -2 and so on, right? Because every time I'm subtracting 1 from that particular number, but we are not saying that okay, after this 1 we should stop, right? Are you getting? So what I need to do, I just need to do if n double equals to 1, or we can say we can stop at 2 as well, because by multiplying 1 or 1, it doesn't make any difference. But let's say 1. So we should go, we should break, or we should return. Return, let's say 1. Otherwise, we should return this one, right? So this is the main condition of the recursion. So let's say if we forget to implement this one, you cannot debug your code and you cannot complete your code without this. So whenever you are writing a function, recursive function, whenever you are using this recursion, first you need to think about this exit condition. If you are getting this formula wrong, like let's say if I'm putting this n minus 2 and I'm writing the exit condition correctly, right? Or we can say simply is less than equals to 1. So I will get wrong output, right? But I will get some output. Are you getting me? Because the formula is wrong, so I will get some wrong output, but definitely I will get output. So if I am getting the output, then I can compare that, okay, what is the expected output and what I am getting. So what may be the possible issue. So I can check this line and I can correct that. But let's say if I'm missing this one, so I will not get anything. Then I cannot understand that what may be the issue. Are you getting? Hey, can you unmute yourself and say yes or no so that I can proceed? Are you getting or not?
Yes, please continue.
Yes.
So for recursion, this is the very basic rule. First of all, you should think about this exit condition, and another one is that formula for recursion, right? Sometimes we have to call that recursive call only once. sometimes we have to call this recursive function multiple time inside a function step. For example, let's say we have function f, right? And let's say we have some parameter x, and we are calling this function like this, f of x minus 1 plus f of x minus 2, or 2x plus dot dot, let's say plus f of 1, like this, f of, let's say, x by 2, like this. So we are calling the same function 3 times. This is also known as recursion, but here also we should put the condition when we are stopping. Okay, so here we are calling this function 3 times, but we need to enter the condition for like for a basic recursion. Sometimes we need to put more than one conditions, because sometimes we have to exit after getting some other condition as well. For example, for factorial, we can exit from 1 as well as from 2, right? If we are getting 1, then only we can exit. If we are getting 2, then only then also we can exit, right? Getting it or not? Okay, so I think now you don't have any doubt with recursion. If you have any doubt with recursion, like how to use, what is the meaning of the recursion, and the basic concept of recursion, if you have any doubt, then you can ask. Otherwise, we can directly jump to the problem, so that we can understand this recursion more, more in more detail. Okay, great. Then let's solve some problem. So the first problem is factorial one, which is we have already solved. So let's come to the second problem. Fibonacci series. So I need a Fibonacci series, Fibonacci a number of, let's say, 10th number of Fibonacci series, or let's say any number of Fibonacci series. So we can solve the problem through DP as well. But for now, let's concentrate on recursion. So I want like this 10th element, or let's say I want a Fibonacci number of particular, let's say I need to check the 10th number of this Fibonacci series. So we have Fibonacci series like this: 0, 1, 1, 2, 3, 5. Then we have 8, and we have 13, and so on. So 1, 2, 3, 4, 5, 6, 7, 8. Let's say 13. This will be 21, and then it will be 34. I think. Yeah. So that would be the 10th number, right? Are you getting?
Yes.
So so just focus about the how you can get this 34. Just tell me. I have already explained these things into the DP, so you can explain the DP solution as well, so that I can relate the DP with this recursion. Let's spend 2 or 3 minutes, so that I can get your input. Then we can I will explain the solution. Anyone?
So in DP, you're memorizing the values, right? So after calculating F0, or like if you are doing say F4, if you are to calculate F10, instead of going all the way back F9 and then F8, now F7 will be computed multiple times. So instead of doing multiple times, you you memorize it, put it in like a memory, and then you access, instead of like calculating it, you access it if it is not there. So if it is already saved, you use the value from the cached value instead of calculating F7 again.
Okay, so like for memorizing this, what we are doing, we are either we can go with the recursion, or we can go like when we are memorizing, we have to put this data somewhere, right? Like how we can remember this 3 or this 2 and all these data? We need to put these data somewhere, right?
Yeah.
Yeah.
You have to
So that
cache it. Yeah.
would be, let's say we are like saving this into a particular data structure. Let's say in an array, right? We can store it, that element into an array. So when we are we need to find this element, we don't need to write a program to find this element. We can simply add these to a number, right? And we can get this, right? Right. Now what I'll say now, the problem is, let's say I have this 34. I just want to know whether the number is this 34 is a member of this Fibonacci series or no. How we can find that?
Sorry, what is the question?
Okay, so we have this number 34, right? I just want to know, let's say I have this number 35. I just need to check whether this number is a part of Fibonacci series or not. How we can find that?
You can keep computing the Fibonacci series until you cross 35 and see if you came across 35 or not.
Okay. Let's say if I'm okay, that we can do. Otherwise, what we can do, we can already calculate the Fibonacci series, and we can store into a DP. That means Bundy array, or in a particular data structure, and then we can simply check, or we can like put these things into a set, and then we can directly check whether 35 is present in that set or not, right?
Yeah.
Okay, great. Okay, now just think that what should be the possible way to make this number as a Fibonacci series. Okay, and for this generating this series, what we can do, either we can go with the recursion, or we can directly go with this 0 and 1, right? When we are going with recursion, we go with this top to down. Otherwise, we can go for bottom to up, right? So top down and bottom up. There are two approach in DP, but here we are covering this recursion one. So just if I extend the same problem, let's say we have this deep array, and we have this array, and now I have this number, let's say 35, and I just want to know that what I need to do with this 35 so that it become the member of this series. Like either I can add something or I can subtract something, right? How we can get this? Are you getting me or not? Question. So we have this 35. I just want to know what should I do with this. Either I can subtract or add, so that it become a member of this series. So let's say I can subtract 1, so I will get 34, and that is the member of the series, right? So how we can find that what we need to do, whether we need to add or we need to subtract. And the problem is, let's say we have the next number is 55, I think, right? 55. So we can either go with this, or we can add 20. We can subtract 1 or add 20. So I should go with this 1 because this 1 is smaller than this 20. So how we can find this?
Sorry, I did not get the question. You said 1 is smaller than 20.
Okay. So
What is-
I have particular number. Let's say I have through this recursion or through this tabular method, I have generated this one, right? This series. Now I got some number. Let's say 35. Okay. I just want to know whether this number is belonging to this series or not, right? That we have done that. Okay, we can directly check into a set or let's say in a array whether the number is present in this array or not, right? Now the second question is, let's say the number is not present. Now I want to modify this number to some number so that it become a part of this Fibonacci series. So either I can go with some addition. So what we can do, I can add 20, so it become 55. That is the part of this series, and I can subtract 1. So this become 34, and this is also a part of this. So ideally we have two possibilities: either I can subtract something or I can add something, but I want with the minimum number of or I should say with the minimum difference. So I should go with this. So I should make it 34. How we can do this?
So find Fibonacci, the number that is either if it is matches, then if the difference is 0. If it is not, then find the one before it and find the one after it, and whichever is closer, right?
Great. So what we can do, we can first of all we can check it. After that, what we can do, we can find this lesser element and the greater element. Or what we can do, but we can directly find the first element which is greater than this, right? So we can definitely get this lower one because this would be a -1 index, right? So we will get these two. Then we can find the difference between these two and these two, and we can get that, right? Now let me share a question with you. This Fibonacci number. Okay, this is the link. Okay, where should I share? Or let's solve one more problem, then we will come, because as many problem as we can solve, that would be good. So the one more interesting problem is Tower of Hanoi. Do you know about this game, Tower of Hanoi? Let me draw the game and let me show the other rules. Right, we have 3 tower. Okay, we have 3 tower and 3 discs, or we can have n discs. For simplicity, let's start with 3 discs. The discs are like this. Now I just need to move all these 3 discs to this pillar, this tower. But the catch is we cannot push, we cannot like keep the disc like this. The smaller disc should not be below this greater disc. So we can do like this. If the disc is smaller, then we can put on that. But if the disc is smaller and we are going to put the larger disc, we should not do this, right? So we need to move all these 3 discs here. How we can do this? Like the final result should be like this. We have these same 3 towers, and all this would be here, like this, and this. Or let me draw it like this, and this. Okay, and this tower is helping you. So this is a very basic game. Generally, we used to play this in our childhood. So or sometimes we can when we are training someone, like when we are training some monkeys or chimpanzees, we start with playing these kind of games. So how you can solve this problem? Like I have to like shift all these 3 discs here, but we cannot move like this. That okay? Let me draw some scenario so that you can understand the problem. Like we have this 1, 2, and 3 like this, and we have this tower. So what we can do? I can push this one here, the small one, and the bigger one here, right? So now, okay, let me draw this in our next level. So what I can do like this, that okay, these two would remain here, and I can push the small one here, right? And now, uh, in the third step, let me draw it again. In the third step, what I can do, I can push this bigger one, the middle one here, right? Now I can so first I push this here, and then I push this here, and now I will push this one here. Let me draw it here. It will have a bigger one. It will have nothing. It will have this and this two disk, right? Now I cannot push this here. Okay, I cannot push this here. So I'm not able to do the operation. But if I do another way, then I may be. So do you want to solve this? Anyone? This is the simple game. I just need to shift all these three disks from tower A to tower B, or let's say tower source to tower destination with the helper tower. This is the problem of recursion, but just solve this without thinking about this program or algorithm. Just think how you can solve this. Then you can understand that, oh, okay, what are the problems and how we are going to solve this. Then I'll write the recursive formula for this as well. Anyone? Hey, am I audible? I need to.
Yes, we can hear you. Fine, actually.
Yeah. So can anyone explain if they have some thought in their mind? I'm not saying that you should write a recursive formula, because if you directly go with this recursive solution, then it seems very hard. But when you solve this problem, or when you solve this game, then it would be easy to easy to you to explain how we can solve this problem. Okay, so let me solve this problem for you. Then we can go with the solution. So just scroll down and let me uh, solve this problem again. So now we have same three towers, right? And let me know when you are not getting the logic, or when you have some confusion. Like we have these kind of things, right? What I am doing, or let's say if you are getting any kind of confusion, then we can mark them 1, 2, and 3. So this smaller block, I am putting this here directly, right? And what I am doing like this, I have this bigger block and then a smaller one, and this is empty now, and I am putting this smaller block here, right? Now again I am doing this. Again I am putting this one middle one here. So if you want to 1, 2, and this one is 3. Again only bigger one remain here. The smaller medium one will come here, and the smaller one will be here, right? And you should till here you can say 1, 2, and 3. Any doubt? Now just think about this, or I could draw it. Wait, let me draw here. Now just think like this. Now what I am doing, okay, here this. Now I am doing this one here. So it will be like this. So bigger one would be there, okay, and the medium one will be here, and the small one would be on the top of this, and this would be empty. So this is 1, This is 2 and this is 3, right? Now, what I can do, I can shift this bigger one to this because this is empty. So we can push this bigger one here. Now this will be the medium one here, the small one here, and the bigger one would be here. So I can say 1, 2, and 3. Any doubt till here? Just let me know. Any doubt till here? So I have fixed this one block at its position. Now the problem is quite simple. But till here, do you have any doubt? Just tell me yes or no so that I can, or you can type in the chat box as well. Okay, so now the problem become, now what I need to do, I have completed this step, right? Now my new problem is I need to shift these two boxes from here. This is the source, this is the destination, and this is the, let's say, helper, right? Now I have sent this block here, right, after performing these iterations. Now what I need to do now, my problem is I need to send this two block to this block. That means this become the source, this become the destination, and this become the helper, right? And I now the problem of solving 3 box, now the problem become I need to solve only for 2 box, right? Are you getting this or not? So after performing these many operation, I just need to follow, because I have only 2 days, so I can jump here and then here and then. Yeah, so after 3 steps, I can complete this. But just assuming that you have 100 days, okay. So after performing these many operations, like some operation, I can shift one disk here, and then 99 disk would be here. So now my new problem become 90. I have to push this 99 disk from here to here with the help of this. That means I need to follow the same operations, right? So when we are doing the same operation again and again and again with less number of complexity or less number of inputs, then this is the classic example of recursion, right? But before going to this, I'm also doing the same operation, that I'm sending something from source to destination, and from source to help, and so on. So we can run this, what should I say, we can from here, this is the main operation. Before this, what we need to do, okay, are you getting this or not? Hello, am I audible? Okay, great, you are getting this. So now you know that I have sent this one here, and now the problem become a whole lesser number. Like now I have n-1 disk, right? N- disk, which I need to send from this to this, right? But just think about this position. Just compare this one and these two. Just forget about this middle one, right? Now I can I say that the problem is not sending all these 3 disks here. The problem is I need to send these 2 disks here and this 1 disk here, right? That is the only problem. What I am doing, I am putting these 2 disks here, and at the last I am sending this disk here, right? And again I need to send back these 2 disks here anyhow, or that is my problem, how I am going to send this. But let's say I am sending these 2 here, and like this. So the same problem, I come to the same problem with the n-1 disk, right? Okay, so what I can do, I can write a recursive function for this, that how we can move n minus disk, n minus 1 disk from here to here, and then I can simply write this logic, that how I can send this disk from here to here. That would be a single line of code, and then again I can write the recursive function to sending the these remaining disks from here to here, right? So that would be the recursive function. So if I call this, let's say the function is tower of Hanoi, okay, and we have n. Now what I need to do, obviously I need to put some this exit condition, right? Why exit condition? Because if we are not putting this exit condition, then it keep on going. So if n is 1, if n double equals to 1, then we can break or we can return whatever we are going to do, we can return it. Okay, let's say return answer. Now what I am doing, I am doing this. Okay, sorry, let me write it again. Tower of Hanoi with n disk from source to destination with the helper node, right? These are the towers, 3 towers. Now what I am going to do, if n double equals to 1, then we are going to return. Otherwise we are going to do what we are going to do, we are going to do tower of Hanoi n minus 1 node from source to helper with the help of destination. Let me show you this one. Just think about from here to here. These n minus 2 node I am sending. N minus 1 node I am sending from source to helper. Source to helper. This is helper, right? With the help of this destination, right? So here tower of Hanoi n minus 1 from source to helper with the help of destination. After this, I just need to move this to this, right? So this is a single line of code. Like we can run a move n, or let's say disk n. So this will be a number n from, or we can say n from source to destination. We don't need a helper here, right? So we can write our move function directly. We can move this last bigger node from source to destination directly, right? I don't think that you have any issue till here. So we directly come from here to here, right? Now we have this position. So now this was the source, this was the helper, and this was the destination. So now what I need to do, I need to send this helper to destination, right? So now what I need to do, I need to do a tower of Hanoi n minus 1, sorry, n minus 1 comma. Now from helper to destination with the help of source. That's it. That's the code. 3 line of code, right? The code is quite simple. When we are talking about the recursion, the code is quite simpler, but you need to understand that how you are going to call the recursive call. So you don't need to worry about these things, how we are doing this, because we don't need. Now if I run this, dry run these things, what will happen if we have 3 dice? So we have like this. Let me show you. Okay, so this condition is not true, so B will go here, right? This will call the same function again, right, with n minus 1. So now I just need to worry about these two. What I will do, again I will call this one. So now the problem become like this. These 2 disks, just forget about the bigger one. These disks like this. Again, because I am coming here and I am coming from here, and this n is greater than this. So again, I will call that I just need to send this disk, right? This disk from source to destination. This disk from here to here, right? Again, I will do this. This disk will be here, and I will move this one, right? Now again, after this, after performing this, again it will call internally, but the now n minus 1 become 1, so I don't need to do again anything. Then I'll move this one. Sorry, this one I have moved this one, right? Now again what I need to do, I have this only node. Now what I need to do, I need to go with this helper, right? I need to move this one from here to here, helper, right? Okay, let me go with this in another step. Now what I need to do, I need to go with this node and this node, right? After this, after moving this, I need to go with this helper to destination, right? So internally this will call, okay, are you getting this or not? Because that's why I explained this before running this program, and then I am explaining this one, because the program is quite simpler, but you have to understand how we are performing these operations, right? Are you getting this or not? Okay, so after this, what I need to do, I simply need to move this one back here, right? And I just need to move this one here, and then I can move this one here. Okay, so I'll solve these things only, right? And then I sorry, this will be here itself. Okay, sorry, I need to push this here. So basically this and this would be empty. This would be empty. Now I just need to move the bigger one. So after this, I just move to this. This operation is done. Now I can move this bigger one. This one. I'll come back here, because this was the recursive call. Inside this, we are going this recursively. After this, because after recursion we need to come back. So now these two nodes are here, and we have this, so we can directly move through this, and then again we can call the same TO tower of Hanoi for this, from helper to destination, right? Any doubt? Any doubt here? So this is the basic problem for 3 days. You can run the same logic with the 4 days, 5 days, and so on, and you can write the program. It will you just need to write these four line of code, and it will provide you the desired output, right? Now let's solve one more problem, and then we can wrap up today's session. So just a simple problem. I have some number, let's say 64. I just need to know whether this number is a 2 to the power n or not. Can anyone tell me how we can solve this? Anyone? We have some number.
Keep dividing it by 2, and if there's a remainder, then exit.
Okay, great. So how we can divide this? We can keep on dividing. Okay. So either we can go with this loop and recursion here as well, right?
Yeah.
Right. So let's go with the loop first. So what I can do, while n is not equal to null, right? Right. And what I need to do, n equals to n by 2. That's what you are saying.
Correct.
Okay, but the problem is, let's say we have 33. So n by 2 would be 16, right? Right?
Yes.
And again, it will be 8, and then
So we should check for remainder, not.
Definitely. So what we need to do? We need to do with if and get reminder 2 double equals to 1, right?
Yes.
we can either get 0 or 1. Then simply we should return false, right?
Correct.
Otherwise, what we need to do? We need to do n equals to n by 2, right? We need to write this. And after this loop, if we are not getting this, what should I say? This false, then at last we can return true, right? Okay.
Yep.
That is the throw loop. Just now let's run the same problem through recursion, right? So we can convert the recursive one into in a loop one as well if we are getting only single recursive function. Like here, I'll just tell you. Here we are getting 2 recursive function, right? So we can solve this problem through loop by hook or crook, but that is quite difficult and complex. So when we are getting single recursive call, then we can convert that into a loop. But when we are getting more than one recursive call, then it would be better to solve the problem through recursion only, right?
Okay.
So here let's go with the recursive one. So let's say f of n, right? Now the first step is, what should be the terminal exit condition? If n get reminder 2 double equals to 1, right? Right?
Yeah.
Then you are going to return. Okay. One more thing. Here you will get wrong answer. Do you know why? Okay. Can you say 1 is the representation of 2 to the power n or not?
It is 2 to the power
Yeah.
0.
Yeah. So similarly here, if we are passing 1, it will fail, right? Are you getting me? Because 1 get reminder to become 1. We also need to put one more condition. If n double equals to 1, then it should return true, right?
Okay.
Similarly here, before this, I need to check if n double equals to 1, then also return true, right? Here return false. Okay. And then, so these are the terminate exit condition, right?
Yes.
Right. Now, I just need to call a recursive function to f of n by 2. That's it. Right? Sorry, not n by 2 like this. Return n by 2. And f of n by 2. So as you can see, in while loop, it looks more complex than this recursive one, right? Getting it or not? So if you are good with recursion, you can solve very complex problem like a tower of Hanoi. As you can see, we have solved in the 3 line only. Similarly, we can go with the tree traversal. Most of the tree traversal we can done through recursion within 3 to 4 line of code. If we are going with the loop, it will take around 20 to 30 lines, right?
Yeah.
So recursion is a very good, like we can say, a concept for solving a complex problem, which we can divide into some problem, and we can find the formula for that, right? So yeah, I think we can wrap